So it's 6 o'clock now. I plan to wait for 3-4 minutes. So in case you guys want to introduce yourself, you can do so. We'll start by 6:05 maybe. We'll wait for others to join since this is the first class. I'm audible, right?
Yeah, you are audible.
So in case you guys want to introduce yourself, you can do so. So let me go first. So hi, I am Shubham Keshri. I am a PhD student at the Department of Management Sciences, IIT Kanpur. My current area of research is operations research, but I have worked with. You see, we will discuss as we'll discuss further. This AI systems are actually based on the search in AI systems are actually based on optimization, and I have quite a bit of experience in optimization. Therefore, I am taking this course. This course is organized by IISS. It is a body of Aerospace Department, IISc Bangalore. And yeah, so that is about me. I'll just go through that again, maybe in the slides or so. So you can start from your end.
Good evening, sir. Am I audible? Hello.
Yes.
You are not audible right now.
Yeah.
Video stuck. Off. Leave करून टाकते. Hello. Am I audible now?
Yes, you are audible.
Right now you also are audible. Hello, sir. Good evening. This is Jairaj. I am currently working as an executive engineer in the Infocom department at ONGC Mumbai. I personally am interested in this course because I just want to learn the basics of Python as well as our company is planning to progress in the field of artificial intelligence. So I also want to learn the basics of artificial intelligence so as to so as to develop few of the applications that shall be helpful to our company. I as okay, huh? That's all from my side.
Okay, thank you.
Hello, Shubham. I'm Sheikh. Previously, we already met in LSO in IIT Roorkee in summer school. Currently, I am pursuing my master from IIT Roorkee. Currently, I am in MTech second year. Now, I am doing internship with Solver Mines. So, I am working on fleet optimization. Yeah, we our meeting meets me to motivates me to attend this.
Thank you.
Thank you, Shubham.
Hello, sir. Hello.
Hi.
Before you, this is Jairaj again. This is
Acha,
Jairaj again.
there's no need to call me sir. You can call me Shubham. Okay.
Hello,
So,
Mr. Shubham. I have a request to you. Before you begin with the session, please brief what softwares those are required and what means on what platform they can be implemented. They can be installed. As currently, I'm using a MacBook Pro. So please suggest the software in the beginning of the lecture which are required to be installed and that can be installed on my MacBook.
all right. I have planned for those discussions. I'll take it up.
Yeah, yeah, okay.
So anyone else? I'll just start in a minute then. You can ask any concerns as well, by the way. All right then. So we'll start. Just give me a minute. So I hope my screen is visible. All right. So how will this course proceed? So you see at your end, you will not be able to see the option of chat. So that is a problem on my behalf. So I was not able to provide you the option of chat. So what you can do is you can just unmute yourself and speak. If you have doubts, you can ask me. Or at the end of the class, if you have a doubt which will take subsequent time, you can just ask, you can stay at the end of the class and we can discuss when everybody else has left the class. All right. Okay. So yeah, welcome everyone. This is the first class for the course Introduction of Artificial Intelligence using Python. Um, Forgive me for this error. This is not about computational thinking. I had used a slide from my previous course and by mistake I have
Video stuck and no audio.
Yeah, your video is freezed and we are unable to hear.
am I audible now?
Yes, yes, you're
Yes,
audible.
sir, you are.
Yes, you are audible.
Yeah, you are audible now.
So I was
Right now,
saying this is what I have planned for today, but I don't think I'll be able to cover everything in this slide in these slides. So let us see how much we can cover today. So first we'll start with motivation. All right. So first of all, you might have in your childhood solved this problem. So this is actually a diagram tracing problem. What you have to do is you have to trace this diagram without lifting your pen or retracing a line twice. So you can take two minutes to try it, and then we'll see what I wanted to convey using this small problem. Just take a minute or two to try solving this problem. The rules are you are not allowed to lift your pen, or you are not allowed to retrace a line again. Just try. It is not important whether you found a solution or not, but how you are trying to solve that problem is more important.
Like so, in this case, we'll start beginning from the vertex having the oddity and finish with the other vertex having this. It's
So
like pointer.
I'll just show you the solution. I hope you have tried once or at least once. So you see, I will say the answer to this problem is not important, but the thing I want to convey, we will see in the next slide. So actually the answer to this particular problem, which I am telling you, is we'll start from this end, we'll go in this direction, then we'll move in this direction, and we can either go this way right. So this is one particular solution, but there are multiple solution to this problem. So you can start this way. So this is second solution, and this is not just two unique solutions, there are multiple solutions to this problem. All right. So what do I want to cover with this? You see, before solving this problem, few things should come to our mind. What is the first question that should come to our mind? The question is this even possible? So first of all, tell me, how are you trying to solve this problem? So I guess most of you would have tried, so used hit and trial method. They would have used one strokes, and then they proceeded, and then they saw that they couldn't solve this problem using these steps. So they went back and then they started again. So this is actually a hit and trial method. You are actually trying all possible cases, right? So this is how we solve search problems, but it is not very efficient way to solve a problem. There are other ways to solve a problem which yeah. So I was saying there are other ways to solve this problem which are more time efficient ways, or maybe space efficient ways. We'll talk about what are space efficient ways and time efficient ways to solve this problem. Before that, the first thing that should come to our mind is it even possible? So when you have tried few number of times and you couldn't find a solution to this problem, you might have pondered about this question, that is this even possible to solve this problem? And if yes, what is the solution, or what is the best solution? There can be two questions: what is the solution, or what is the best solution? So these kind of questions comes under optimization. And optimization is a very essential tool used in search algorithms when AI is performing a search, or artificial intelligent agent is performing a search. All right. So what are the key takeaways? The key takeaways is just solving an individual problem is not enough. If you are given a particular problem and you have found a solution to that problem, it doesn't mean that you will be able to solve any similar problem, right? You have to find such solutions which can be generalized. So those are known as algorithms to solve a problem. So some generalization, some steps which you know will give you the solution, will always give you the solution. So one way to solve this problem which will always give you the solution is hit and trial method. You try all possible cases, all possible ways to construct that diagram. And when you exhaust all possible case, you will be able to answer this question: is it possible to draw the diagram? And if yes, what is the solution? So this is one solution approach, or one algorithm that can solve any problem. So I had given you this diagram. There can be other diagrams as well. So for example, you can have this diagram, and you may be asked to check if you may be asked the same question to retrace this diagram, or there can be any other diagram as well. So generalization is a very important concept in artificial intelligence, not just in artificial intelligence, in optimizations as well, where given a problem, you can identify what is the structure of that problem, and you can use established algorithms to solve that problem. All right. And one more thing which we noticed is that there can be multiple solutions to a problem. So for this problem, there was multiple solutions, but all those solutions was acceptable, because you cannot distinguish between one solution or the other, right? So solution 1 is same as solution 2, but there might be cases that doing solution 1 is costing you more, so it is more costly than doing solution 2. So in such cases, you have to think to pick a best solution among a set of solutions. All right. So what happens if there are multiple solutions, and even the case comes when you have uh, solutions which different qualities. Some may have a higher cost, some may have a lower cost. So you have to pick the best among the all possible cases. All right. So this is one motivating example. Now you may ask that this is a very trivial problem which we have solved in childhood. How is this problem related to real life? This is not a real life problem. So in the next slide, I have posed a real life problem. But before that, can anyone give me an example where this abstract problem can be applied in real life, or the real life problem can be brought down to this abstract problem? What are you doing? You are given some paths or some edges in technical term. You have to trace, or you have to follow the paths exactly once, and you cannot jump from one end to the other. So any real life example you can think of?
Salesman's covering multiple locations.
Right, right. So that is one such problem, but it is not a similar problem to this problem, but yeah, quite similar. Both are not same problem, by the way. All right. So I'll give you one more example. Before that, do anyone else wants to guess a similar problem?
It's route optimization for like delivery partners and all.
Right. All right. So you see, this is one example of such problem. This is known as Königsberg Bridge Problem. So what this problem is, in 1736 or something like that, in that year, around that year, Euler, the mathematician Euler, was asked this problem. So there was a city, Persian city of Königsberg, where they had islands, and these islands were connected with bridges. So I have named these bridges 1, 2, 3, 4, 5, 6, 7. These are 7 bridges in that island. And the resident of that city wanted to know if it is possible to travel or to do a walking tour of the town, crossing each of the 7 bridges exactly once. So what they wanted to do is they wanted to travel all the bridges and take the tour of the city using that bridges, but they wanted to travel each bridge exactly once. So you can try again. So you can start from here, maybe go here, then go here, and you can just try. This is also again hit and trial method. And if you think about it, this problem and the previous problem is very similar. So I'll just show you. So what I have done is I have transformed this problem into an abstract model. So this is known as a network model. So this is, what is this? This is a network model of the same problem. So when we are modeling, we generally lose data. So you have to decide what kind of data you are willing to lose, such that you find a solution and that solution is useful to your problem. So I had a problem, a real world problem. And what I'm doing is I'm abstracting the problem such that I can solve it. But during this abstraction or during this modeling, you will lose data. So what kind of data you will lose, you have to decide. So over here, what I have done is these land masses I have converted into nodes, right? So these are nodes A, B, C, and D. So this is A. This is B, I guess. No, I have to check first. This is B, this is C, and this is D. All right. And I have already named the bridges. So bridges are here, the edges in this graph. So this is actually a graph. In mathematics, this is actually a GRAPH graph. All right. In this graph, these nodes are the land masses for this problem, and the edges of this graph are the bridges. So solving this problem and this problem will give me, so solving this problem will give me a solution to this problem, right? Both are not same problems. This is a very abstract thing. This is a graph, but still you're solving this problem and you're getting a solution to this problem, right? So this is known as abstract modeling of problems where you lose data. Still, you want to solve that problem because the solution to that problem will be useful to you in your real life. Now, if you see again, this problem is same as the previous problem. You are tracing these edges such that you trace each edge exactly once. You cannot jump also. So you cannot jump from bridge 5 to bridge 6. How can you do that in real life? It's not possible. So these are restrictions to a problem. These are known as constraints. So what are the constraints to this problem? You cannot travel a bridge twice. You cannot jump from one bridge to the other. So these are the constraints to this problem. All right. So this is one aspect of modeling a problem. All right. So if you see both of them, both are same problem, exactly the same problem, right? So what we were doing in childhood was asked to Euler, the great mathematician, in the 1700s. All right. And what Euler did is, so it is not related to this course now, I'll just give you for curiosity. So what Euler did is he came up with a such kind of solution that given any graph, doesn't matter how many edges it has, how many nodes it has, he can tell me or tell that is it possible or not. So even it is possible or not, he can tell me quickly, very fast, that yeah, it is possible to do a walking tour such that you cannot travel a bridge twice, more than once, and you are not jumping from one bridge or the other. So that is what he did, mathematically proved. All right. Now, the other aspect I wanted to tell you is this is actually a search problem. So this is a very important aspect of artificial intelligence. And I have taken a lot of examples to put this in your mind that search is a very important aspect of artificial intelligence in this slide itself. So we'll proceed and we'll see other examples of search. Before that, you have to realize that this is a search problem. Think about it. So when you are tracing a path, so suppose you have started here and you have went at this node. Now what are you doing? You are trying to search, or you're trying to find the next. Please mute. All right. So what I was saying is this is actually a search problem. So beginning at a node, at any node you can start. Beginning at a node, you are trying to find your next step, right? So from here you're trying to find where should I go next. So you are saying I'll go here. All right. Then what is the next step? So you can either go to this node or you can either go to this node, right? So you're finding paths. So one such example can be finding routes in a map, Google Map. So whenever you type a destination in Google Map and you just find, click the button on take me to that navigation, whatever it is, that algorithm runs in the background and finds the shortest path for you from one node to the other. So it is actually the same problem, not the same problem, but the modeling will be very similar. So your source will be a node and the destination will be a node. So this is the source node, this is the destination node, and there will be multiple turns in your path to that destination. What Google Maps does is it will find a path which will take the least amount of time. All right. So it will go through all possible paths. It has an algorithm to do that in real time. In real time, I mean quickly, and then it can give you a solution very quickly. All right. So this is a search problem. This is very important, and we'll see this subsequently. All right. Before we move on, I want to share one more problem with you. This is known as the Chinese Postman Problem. All right. Before discussing the problem, do you have any questions, doubts, etc.?
Sorry to ask this. Can you say how we are losing data by
Right.
converting to this model?
So how are we losing data? So if I give you this problem, this problem, maybe, right? So can you tell me what was the context of this problem or this problem? So if I give you this graph and I ask you the same question, retrace the line. You cannot retrace one line again, and you cannot jump from one line or the other. So can you give me the context of the problem?
It's a bridge problem.
Right.
It's a totally different from like reality, and after converting it is into this diagram.
Right. So what I'm saying is, if I give you this graph, suppose this graph I give you, and I ask you a simple question, what you have to do is you have to trace all the lines such that you cannot trace one line twice and you cannot jump from one line or the other. So will you be able to tell me the context of the problem with just this description?
No.
Right? So you are losing data. You are losing data that this is a landmass, this is a bridge. You are losing data, right? But those are not relevant for the question you are asking. So you can afford to lose those kind of data.
Okay, man. Okay, Shubham. Shubham, which method it is?
Method? We have not talked about any method.
You said na like we are modeling into this diagram. You said something.
This is a network model. This modeling is network model.
Okay, Shubham.
All right.
So, sir, how do you create these network models? Like, how would you understand that where should be A, B, C, and D, and how do you bridge those gaps between them?
So those will come with experience. So the more you solve such kind of problems, the more intuitive it will become to you, right? This may be a node, this may be an edge. So those will come with experience. Unless and until you experience such kind of solution methods or modeling of such problems, it will be difficult for you to do that. So I'm not saying you will not be able to do it, but you should have experience.
Understand. My concern was like, are we going to learn about these nodes and models and how to create these as well going further, or like we have to understand them by taking in problems ourselves and then reconsidering and understanding where they should lie?
So you see what I am discussing over here is a field in all different domains. So this comes under mathematical modeling, mathematical optimization and all. So we'll not go in depth with all those. Okay. And when you learn on how to solve a problem, maybe you will not be concerned about how to model a problem. Yeah, you will be, but this course will not take you in that direction.
Fair, fair enough, sir. Thank you.
Yeah, someone else was asking me something.
So, hello, Shubham, this is Jairaj. So,
Yes.
when I convert a specific problem into a network model, then is it necessary that modeling shall be specific, particular to that solution, or the model can be trivial? For example, say two persons are modeling same problem. Then can the model things by two persons be different, or are they necessarily be same?
So
Because
you.
it solution depends on the modeling. Am I right?
Yes, yes, yes,
So
yes.
can
So
our models necessarily be same?
no. So actually modeling is an art. The more you do, the more better you get at it. So modeling this problem in a network model may make it simple to solve. And if you model it mathematically using variables, then it may become difficult. I'm not saying this will become difficult. I am saying it may become difficult. So identifying those nitty-gritties are also important um, to learn, right? So which model will be better for me and which algorithm. So because if you model it in a network model, you are using different kinds of algorithm to solve that problem. If you are modeling it mathematically, you will use different kind of algorithms to solve the same problem. So some algorithm may be better than the other, right? So there are
So
multiple ways to solve a problem.
yeah, means no doubt there can be multiple ways, but output or outcome can be same or it can be different. Means
No,
I
so if you're,
started from A, wanted to reach at C. My
yes,
model must result in reaching at C, and your model must also result in reaching at C.
yes,
Irrespective of modeling, the
yes.
result must be same.
Yes, so that is the core concept of solution, right? So you want to find a solution to the problem. So if my solution satisfies the problem, your solution is also satisfying the problem. Both are solution to the problem. How
Yeah,
we have derived the solution is a different domain altogether now. So the solution is more important to us, right?
yeah. Oh,
Any more questions?
Shubham, how are we going to take like if I'm using it for search and avoidance algorithm, so how the input is going to differ from normal search problems?
So we will discuss those things when the time comes. This is just a motivating example. We'll discuss all those details as we proceed.
Okay, okay,
Okay.
thank you.
So I have a question.
Yes.
So suppose I am making a model of this problem, and another person is making the using the same problem and making a model. So is it necessary that both of them will make a similar model to solve the problem, or the models can be different?
The models can be different. All right, so this is a same, very similar kind of problem in spirit. So you can just read or I'll just discuss. So this is a Chinese postman problem. This is a very popular problem in literature. So what it says is this Chinese postman wants to travel along each road. So these are roads from A to B. These are roads, and A and B are, you can say, corners or maybe cities. You can say either of those. They can be corners in a lane or they can be cities in order to deliver letters. So this postman wants to deliver letters in the road. So when he is crossing that road, he wants to deliver the letters in the houses which are beside that lane. What is the least possible distance he has to travel? So he has to travel all the roads. All right. So this is the first constraint, you can say. So you have to travel all the roads. So it is same to the previous problem. Now there are two things which are different to this problem as compared to the previous problem. Can you tell me what are the two things that are different? I'll just repeat the problem again. So in this problem, a postman wants to travel each of the lane in the city. So or maybe multiple cities are there. He wants to travel each of the lanes connecting those cities such that he travels the least distance, and the distance are mentioned over here, right? So there are two things different from this and the previous problem. The first is, which is same, is you have to travel all the roads. So each road has to be traveled. What are the two things which are different from this problem than the previous one?
The postman can travel the same road twice also.
Yes. So you can travel an edge multiple times. There is no restriction that you have to travel an edge once.
But
That's
if,
the
if
first.
I'm not wrong, if I am not wrong, to cover a least possible distance, you cannot travel same road twice.
That is not important. You see, when I was telling you this problem, when I'm asking you, is it possible? So suppose I draw some diagram. I don't know if it is possible or not. So suppose I'm drawing this kind of diagram, or maybe this kind of diagram, and I'm telling you to trace this. Right? So I'm asking you to trace this. So you don't know if it is possible or not without retracing it. If I allow retracing a path, then maybe it is possible, right? So retracing may be helpful, right? So suppose there is roads like this, right? And like this. How can I do it? I'm not able to think about some example. So suppose there is one graph where it is not possible to trace all the paths exactly once, right? So in such cases, you may have to retrace the path back. So in such cases, you have to decide which route you want to retrace. So that is one question, right? Such that the distance should be minimized. So one difference is there is no restrictions on T restriction on retracing path, right? So what is the second difference from the previous problem? You see over here you have an objective to fulfill. You have an objective function. You want to minimize the distance. Over there, the thing was, if you traveled all the paths, that is it. I don't need to know about what is. So all solutions are best solution. Whatever solution you give is the best solution. Over here, all solutions may not be a best solution. You have to decide which solution is the best solution. So this is also a search problem. This is also a search problem, but it has an objective function. So you have to pick up that solution, which is the best solution. So these two are the two difference between the previous problem and this problem. Is that clear? So
Yes,
the only constraint. So the only constraint in this problem is you have to travel all the paths. That is the only constraint in this problem. All right. So yeah, that is it. Now, so you may ask again. So these, yeah, Sagar, do you have any question? Okay, so you may ask again, so these problems are very theoretical or maybe related to very particular domain like a postman. How is this related to artificial intelligence? So I have taken few applications of this problem to make you realize that these problems are also important to an agent, artificial intelligence agent or AI agent. All right. So one example is robotics and path planning. So when there is a robot and you have an arm of a robot and you want to pick an object from one location and keep it in other location, there can be problems in similar spirit that you have to find the path such that it is taking the least amount of time or the least amount of distance or some such application. So there may be a software who is deciding the path the robot is taking, right? The second is network routing and telecommunication infrastructure. So when you have when there is some company who is building its network or this routing network, so they have to decide in which area they have to put the optical fiber. So those also comes under such kind of problems. Very similar in spirit, maybe not the same problem, but very similar in spirit. The second is transportation and logistics. So there can be delivery vehicles. So somebody has was saying the same problem, efficient travel and reduced cost. So there may be, so this delivery guys, this Flipkart delivery guys, they come in the same path every day. So they have to decide. So once it is decided, so they do not change. But for example, if it is changing for something or the other, so there can be some such problem. In urban planning and infrastructure, garbage collection. So there is a garbage truck and they have to travel all the lanes in the city. They cannot skip a lane and they have to decide in such a way that they travel the least path because that will cause them the least amount of fuel. Street cleaning is also an example. Game development, so an AI character, maybe you have some games and that character is deciding some kind of, so for example, that game was there. So it is not similar problem, but for example, there was a game like snake and that eating of food for that snake. So there are some kind of similar ideas, not the same problem by the way, but I'm giving you some ideas. So some optimized path for an AI control character such that the game is played. Inventory management, so there can be autonomous vehicles which are traveling some warehouses and it is doing its work. And by the way, this robot example I have given you some cleaning robot also. So you have a robot at your home which is cleaning your house and he has to travel all the areas. So there can be some such ideas as well. Okay, so drone and aerial surveillance. So in drone and aerial surveillance, you have to follow some paths and do the surveillance. So these are some applications, maybe not the same problem, but very similar in spirit. And yeah, so these are some motivating examples. So I'll just proceed forward before I go. If you have any doubt, then you can ask me, right? Okay. So what is our course design? You see, real world problems are very complex. So the problem which we saw, that bridge problem, there are many challenges. And what do we require at the end of the day? We require to build a software or hardware solution. And there can be significant gap between some theoretical problem you can work on and some practical application of that problem. So what this course will do is it will provide you a structure of how to solve a problem, how to tackle a problem, systematic methodology of solving a problem, right? It will introduce you some frameworks of how to plan a problem, how to go about solving a problem, how to deciding what kind of solution approach you will take to solve the problem, and so on and so forth. You just cannot go and sit and just start coding, right? You have to decide structure and then you will work forward to solve that problem. So we'll follow a similar path. Now, again, I'll tell you, so we'll use Python very minimally. I'll not use Python in the class, or maybe just to discuss the assignments and all. Will not. So Python is not required to understand this course. You can understand this course without having learned Python. All right. So this course is designed in such a way that anyone can understand this course without having any knowledge of Python. You require Python just to implement the algorithms you learn over here. So at the end of the day, what you want to do is you want to implement this study whatever you are doing. So in such cases, you have to learn Python and implement those algorithms such that you solve a problem in real life. So in that way, Python will be required. To understand this course, Python is not required. All right. So course objectives, so this is what I am discussing is actually the first course handout. I have sent you the first course handout. So this course will introduce you to artificial intelligence and intelligence system, and we'll explore this algorithms, techniques to solve a problem, and so on and so forth, right? Learning outcomes. So we will learn about knowledge-based representation. So how AI systems represent knowledge. So actually we will see what, when we say AI, what do we mean? What are the aspects of AI, key aspects of AI? We'll see those things. And those are the discussions I'm doing here. So we'll learn about knowledge representation. How does AI represent knowledge? Because you can see when you chat with a chatbot, and if it is an intelligent chatbot, it can give you very intelligent answers. So it has knowledge about our world, right? So they are representing how these AI systems are representing those knowledge. We'll understand that how problem solving is tackled by an artificial intelligence agent. We will learn techniques in artificial intelligence and so on, right? Yeah. All right. So some prerequisites. So you should have some basic knowledge in Python. If you don't know Python, please go and learn Python, because if you don't solve the assignment problems, this course will be half help for you, because you'll just understand the concepts and you'll not be able to implement it. So it will be just not beneficial for you to do this course. If you don't submit the assignments, you will not be able to learn. So it is not important to submit, it's important to solve the problems. If you don't solve those problems, it will be difficult for you to grasp the concepts taught in this class. So please go back, learn Python, and then solve the assignment problems. Probability and statistics little bit idea is important, because AI is all about mathematics and statistics. So if you have little idea about that, then it will help you. I will discuss the basic concepts of probability which we'll use in uncertainty. So real life has uncertainty and AI agents deal with those uncertainty. So when we discuss how AI agents are dealing with those uncertainties, we'll have to have the knowledge of probability. So in such cases, you should have some background on probability or maybe willing to learn probabilities, because I will take I will take it in a way that you will be able to understand whatever we discuss in this class. This I'll not cover. I'll try to cover as much as I can, but this is not the focus of this course. And some basic understanding of data structure, algorithm, and logic will be helpful. So this is also a very important domain of study. Because when you are solving some problems and using algorithms, then you should you should have some idea of how to write an algorithm, what are algorithms, and so on and so forth, right? So what are the contents of this course? Today we'll discuss the introduction of artificial intelligence, and I'll go to search algorithms as well. So as in the motivating example, you saw that search is very important to understand, because AI agents deals with search algorithms, because in real life we perform a search a lot. Just a minute. So some algorithms we'll learn is depth first search, breadth first search, greedy best first search, A star search, min max search, alpha beta pruning. Then we'll see representation of knowledge and logical inference. And before I proceed forward, I have given an assignment today on logic. So go and learn, solve those problems. Those are very intuitive problems, but yeah, those are fun, by the way. And yeah, so we'll learn about probability and uncertainties. We'll learn optimization and constraint satisfaction. So just to give you an idea, the first problem which we discussed, the retracing of line or the bridges problem, those were constraint satisfaction problem. It did not have an objective function. So when you have an objective function, then it becomes an optimization problem. All right. So a constraint satisfaction problem is that you have to just satisfy the constraint and find a solution. An optimization problem is such problem that you are searching, but you are searching for the best solution. That solution which either minimizes or maximizes the objective function, whatever you are looking for. So if you're looking for maximization, the solution will maximize. If you're looking for minimization, the solution will minimize. We'll learn machine learning. So you see, these are very broad areas in itself. So machine learning is a broad topic in itself. So we'll not go into very deep on how machine learning is done, but we'll give you enough idea on how those algorithms are developed, the intuitive understanding of the very fundamentals of those algorithms. So with this idea, if you proceed if you decide to learn machine learning, then it will be very helpful for you to proceed in this area. All right. So this is how the course is developed. It is a broad course. You will get idea of each and every aspects of artificial intelligence. And if you want to proceed with this base, it will be helpful for you to proceed. We'll go over neural network and deep learning and some natural language processing. So these two will not be in a lot of depth, but yeah, you will be able to understand how are these working, how natural language processing is working, and so on and so forth. My idea is to complete this course in 12 classes, but I guess I may need 1 or 2 extra classes because I'll be on leave in between some of those classes. So I'll inform you in a priori about some changes I have. All right. And I'll see if it takes a little more time. I can extend the course if you want, but I'll cover everything which I have planned over here. So the course delivery, we'll have live classes on Sundays. You know these all those things. This is important. The resources will be available over here. So if you go to this website, so all the details will be available over here. And if you forget the website link, you can just search my name. I guess this is the first link I'll get. Yeah. So this is the first link you will get, and this is my website. You can go to the resources tab, and this is the page I have created for this course, and all the details will be here. But to submit an assignment, you have to go to Google Classroom. I'll discuss that next. All right. So all the notes and discussions will be in Google Classroom. I'll just show you. This is the home page of Google Classroom. So over here, I'll just go back. Over here, you will see all the courses you are enrolled to. So currently I am enrolled to 2 classes, and this is the class which you will be in. So I have posted in that welcome email which I had sent you. So you can just read this, and there are links to join this class as well in this post. I'm not showing the link because this will go in YouTube. And over here you will see assignments and homeworks and everything which you get. So you can just go here and click and just submit it. And yeah, you will just be able to see who are there in the class. One important thing you have to understand is that you will not be able to use your work email ID to sign in this Google Classroom. You will have to use a Gmail ID to sign in this classroom. So I have sent you the link in the group to sign in this classroom. Please do so. And this assignment will be due on this Tuesday. So you have to submit it before that. And this is a graded assignment. I'll tell you the grading policies. Sorry. All right. So yeah, so this is me and these are my email IDs. Assessment is class participation. So I will try to give you a quiz at the end of every class. If I'm not able to, then forgive me for that. But there will be assignments. So this class participation attendance engagement will be monitored. So in the sense that when you attend this class, I'll get an Excel sheet after this meeting. I'll mark that attendance with that. And engagement will be monitored in this discussion section. So when you go over here, you can post your questions, whatever you want, and anybody can reply to that question. So I can see who are discussing more and engaging in the class. That is the idea. So it is 20%. Assignments will be given to you at each module. And this is the major part of this course. You will be given assignments and you will this assignment will reinforce the understanding of the course. This is 50%. And there will be projects. So please form groups from now only, because it will be beneficial for you later on. So you have to submit this final project, and this project is mandatory to submit if you want to get a certificate of completion for this course, and you should have a minimum of 60% for this assessment. And moreover, one thing I want to tell you is that issue of certificate is not on my hand. I will communicate with you and also communicate with the ISSS team to submit you, so to provide you the certificates. So on that end, there is not much to do for me. I'll just help with that. All right. So learning books and all I have given you. This is not much. And recommended tools. So some was asking me how to do it. So you can install Anaconda, and in Anaconda you will get Jupyter Notebook. So this is a Python environment where you can write Python code. If you don't want to install anything in your computer, you can use Google Colab. It is a very open source platform, online cloud-based platform where you can write Python codes very easily. And yeah, so you will be able to use Google Colab in your web browser, and it will not be installed in your computer. And one more thing I forgot to tell you is that whenever you submit an assignment, I'll give you the instruction, but please submit in PDF. All right. That instruction of submission will be given when the assignment is live. All right. So this is it. We will start. Do you have any questions in the first course handout or anything you want to discuss?
Will we be solving any optimization problems?
So it depends on you. So if you ask me, I can give you. But yeah, so this problem, there is one module on optimization. In those assignments, I can give you optimization problems. But again, optimization is a part of artificial intelligence. Artificial is a broader umbrella. So it depends on how you want to proceed.
All right, thanks.
Any doubts? All right. And one more thing, I have seen that most of you have not joined Google Classroom. Please do so, because all the announcements will be given there. You can use WhatsApp chat also, but in WhatsApp chat, things go here and there, and it is very difficult to keep track. So using that platform will be beneficial. Moreover, you can see your grades and assignment deadlines and everything over there. All right. So let's proceed.
Wait, Mr. Shubham.
Yes.
I just have a query. As I was discussing with you, I have a MacBook with me. So the two recommended tools can be installed on the MacBook, means NumPy or Pandas, Scikit-learn, any of them.
These are not to install. These are libraries which you can just import in a Python file, and you can just do it.
Software, which platforming tool?
So if you don't want to install anything in your computer, you can just use Google Colab. It is free.
I want to install something on my computer to learn the
Okay.
Python.
Okay, so I am using MacBook and I have installed Anaconda in my MacBook and it runs fine. In Anaconda, you can access Google Jupyter Notebook.
Is Anaconda freeware?
Yes,
For
yes, it is
MacBook?
available for free. Everything is free. All of the things I have mentioned here is for free.
Okay, thank you.
Yes, Ruchi?
Sir, suppose like I don't have laptop or computer, so can I do this program on my Android phone?
So if you don't have a computer and you're not able to do these tasks, so what I would suggest is whatever problem I am giving, you can write pseudocode. So you have to learn what a pseudocode is. It is just like plain English. If you go to my first lecture on Python, so I have a Python course uploaded. I'll just show you. That first course talks about writing pseudocode. So yeah, so this course on Python I had done. So over here in the first lecture itself, I have shown one example of pseudocode. All right. So you can just go there and see how pseudocode is written and you can just submit using pseudocode and submit the assignment. So you see, I am telling.
Also do it with the help of Google Colab.
See, writing code in a phone will be difficult for you because there needs to be some tab and all. So it will be difficult for you to write in phone using phone.
Okay, sir.
Anything else? Okay. So what is artificial intelligence? Artificial intelligence is simulation of human intelligence. So you see, humans have always wondered about the capabilities of a human being, and they have been fascinated by it, and they are also wondering how they can mimic it in a machine. So this is what artificial intelligence is all about. They want to simulation of human intelligence processes by machine, particularly computer systems. These processes involve learning. So we'll talk about what learning is. So it is actually acquiring knowledge and applying rules, reasoning, using these rules, draw conclusions, and self-correction. All right. So what is self-correction and all we'll see in subsequent classes. But this idea, using these rules and drawing conclusion, it comes from logic. And today's assignment is based on logic. So go through those assignments. It will help you just have a basic understanding of logic. All right. So this is the basic definition of artificial intelligence. What are the key aspects of artificial intelligence? Learning is an important aspect of artificial intelligence. It talks about how machines acquire information and apply those acquired information in real life. And how is this information acquired? It is actually based on data. We'll see that when we talk about machine learning. So you'll see how data is used to train. So these are technical terms, train a model. And by a model, we means a software system.
Sorry to interrupt you, Mr. Shubham.
Yes.
Are you sharing your slides with us?
Yes.
Okay, okay. So that we can fully concentrate on the lectures and not on the noting down the important things.
Everything I will do in the class, I'll share it with you.
Okay.
So, Amrita, do you have any doubt?
No, sir.
Okay. So again, the key aspects of artificial intelligence is problem solving. So we have seen one example of a search problem. There can be other problems as well. So finding a solution autonomously. So you see, whenever you are encountering a problem, you don't have to model it and give it to a system to solve it. In that case, it is not an artificial intelligence system. An artificial intelligence system should have the idea of taking new kind of problems and solving it in their own. All right. So this is what problem solving is. Reasoning. So again, using of logic and rules to draw conclusions. It is important that they are drawing conclusion. So again, again to that example which I was giving you, that quiz, they have in the quiz, what is there is some statements and you have to draw conclusion from that statement using logic. So you'll see in that assignment, or not assignment, quiz, and make inferences. Decision making. Artificial intelligence can make informed decision by evaluating options and predicting outcomes, and use of algorithms and data structure. It relies on the basic of algorithms such that it can actually do anything. So yeah, what is an algorithm, by the way? Can anybody tell me what is an algorithm?
A set of procedures to solve a particular problem.
Right. So algorithms are just step-by-step instruction to solve a problem. This is what an algorithm is. All right. Step-by-step instruction such that a computer understands it. So let's ponder upon. So this fascination humans has. So what are the capabilities humans have, and they want to mimic those capabilities in a machine. So perception. A human can recognize objects, interpret and interpreting sensory information. So a human can recognize an object. So if you're writing in plain, so when you are writing in handwriting, so a human can recognize those handwritings. So currently there are softwares which can recognize handwriting and convert it into text. So this is one such perception capability a human has, and they want to mimic it in machines. Robotics, physical manipulation and interaction with the environment. For example, I gave you that mechanical arm or a robot. They can move from one place or the other. Language, so they can communicate. So humans can communicate and understand spoken and written words. So we want to mimic this also in machines. Knowledge, so accumulating facts, concepts and experiences. So if you go to a chatbot, I cannot name that chatbot. It is a very popular not a chatbot, actually it is a natural language processing model. And if you ask factual questions to it also, then you will get, it may be wrong, but it will try to give you as correct as possible. So how are they doing it? How are they recognizing these facts and then producing it when necessary? So it is not important to produce when we are talking about knowledge. It is important how are they storing those information in between them? How are they keeping this knowledge with them? Reasoning, so again this is about logic and decision making and learning. So picking up information. So for human beings, so think about a child. So when a child is born, he or she neither has any knowledge of walking or speaking or anything about the world. Whatever its experiences, through those experiences a child learns. So if a child is born in a French family, he or she will be fluent in French because the experiences he or she is having is in French language. Similarly, if he is born in India, he or she may learn an Indian language, maybe Tamil, Telugu, Hindi, or so on. Right? So these experiences are important, and machines also learn through experiences, and we will see the difference between a learning of a human being and a learning of a machine. So what is an AI agent? An AI agent is a software entity designed to autonomously perform tasks and perceive the environment. So the perception which we talked about, reasoning, acting to achieve specific goals. What are the key characteristics of an AI agent? Autonomous, so they are independent. They don't need human intervention every time they make a decision. Perception, so we talked about this. Reasoning, action and learning. So reasoning is about taking information and then drawing some conclusions. Action, performing some tasks like manipulating objects and so on. And learning, so like humans learn, machine also learns from data. So that is the aspect of learning in an AI agent. What are the key challenges of an AI agent? You see, AI agent, so what are the differences in human beings and AI agents? You see, human beings require very limited amount of data to learn. On the contrary, when we do machine learning, we try to give as much data as we can to a machine such that it gives appropriate results, right? So a human may require less amount of data. So the data requirement, I'll come to task. So when I'm talking about data requirement, machines may need millions of examples to learn. And in the other end, if you talk about human beings, it may be less, not maybe in hundreds maybe, or even less, right? For tasks, AI agent can excel in a very limited amount of tasks, but they can do it very well. So for example, if we talk about face recognition, or so human beings can get confused into two similar looking faces, but an AI agent will not. So they can be very efficient in some particular limited task. On the contrary, human may not. Specialization, it is the same thing, that a particular area AI agent can be more um, uh, excel in that. Human versatility, so we have talked about this. Yeah, so human can perform a wide range of tasks and replication. Yeah, we have talked about this, that human can adapt to a large environment and they can do a lot of things. Moreover, they require less amount of data to learn, right? So this was the key idea of this slide. Any questions? Okay, so AI tools, what are, so we have talked about AI agents. Some people talk about AI tools and AI agents similarly. So generally speaking, when a person talks about AI agent, they think about a sci-fi movie character, that a human like robot and so on. But in general, AI agent and AI tools are very similar. So what are AI tools? They are actually intelligent systems which enhance human capabilities by automating tasks and improving decision making. So for example, if you are using a software for grammar checking, it may have an artificial intelligence system which is helping you to write properly. You can have a face recognition system. So self-driving car, they are aiding humans in their day-to-day activity. Authentication software, so for example, face recognition. So Apple has a very good face recognition software in their systems. Chatbots, weather predictions. So human beings are very so when they predict weather, it might not be as accurate as a prediction made by an AI agent. There are many other examples or applications of AI tools. I have given few of them. So for example, healthcare. So in diagnosis of diseases also, AI can be very useful. They can learn from the previous data and then they can predict what can happen. All right. So this is the summary on introduction to artificial intelligence. I'll move on to the next part of our lecture, which is search. Yeah, it is search. So this was about introduction to artificial intelligence. Do you have any questions? All right. So you see, we have a 2-hour class and it might be tiring for you all. So every day at every class at 7 o'clock, we'll take a 5 minutes break and we'll start again. So currently the time is 7:02. We will meet at 7:07 and we'll start with search. All right. So you can come back at 7:07. So if you have any doubt, you can ask me. I have 2 more minutes.
Hello, Shubham. Finally, we need to do project, right? For that, will you give problem statement or otherwise we have to find out by ourselves?
So both option will be there. I will give some problems and you are free to choose whatever problem you want to do. So you see,
Okay.
I'll not be very strict in grading, you can say, right? So I shouldn't openly announce this, but I'll not be strict with very this grading because I want you to learn. So when I become strict, people don't take this course seriously. They may leave the course. So it is up to you how you want to do. So I just want you people to learn. Yeah.
Yeah. Thank you, Shubham. Thank you so much.
Okay. So this is another yes, yes. Someone was raising their hand. Yes, we do.
Yeah. Yeah. Hello, Shubham. I'm
Yes,
audible.
yes, yes.
Yeah. My name is Vibhu Shukla and I am from FMS New Delhi. And right now I'm currently working in Adit Birla Group. So I want to ask you, AI replace humans in what term? Can it be replaced? And what technical skills should human have so that AI cannot replace them?
So those are ethical concerns of AI, and I have
Yeah.
not taken that part in this course, but I can take those parts maybe later. So those are ethical concerns, and we have a small portion on each course on AI. Whenever AI courses are taught, it talks about ethical concerns. So I
Okay.
can take that up maybe later.
Okay, sir. Thank you.
Okay, so yeah, so we will proceed. So this is another famous problem which we used to solve as children. So try once, and the problem solution of the problem is not important, but how are we approaching that problem is more important. Yeah, so you can take your time, maybe 2 minutes, and try to solve this problem. So there are two questions I have mentioned. Can the farmer get all the three items? So I'll just, yeah, I should read the problem once. So there are four, you can say, entities in this problem. The first entity is a farmer, the second a fox, goat, and a cabbage. So there are four entities in this problem, and they want to cross a river. Now there are some constraints. So we are using technical terms now. So there are some constraints. They can use a boat, but that boat can hold only two items at a time. One should be a farmer because he has to row the boat, and additional one more item. The farmer cross cannot leave the fox and goat alone, and goat and cabbage alone. So these are the constraints of this problem. All right. So there are actually three constraints. Can anybody tell me what are the constraints to this problem? Actually, four maybe you can say.
You can take only one item.
Yes. So boat capacity is two. Boat must have farmer. Fox plus goat cannot be in one side, and goat plus cabbage cannot be on one side. So these are the four constraints to this problem, right? Achha, one more thing. Does this problem has an objective function? So there are two questions. First question is this, and the second. Yes.
So what is objective function?
You are not clear, Dheeraj.
Hello, I'm audible, sir.
Yes, yes.
Sir, I'm asking about the objective function. Like I don't know about in detail about that thing.
I know you don't know. So we discussed it in the motivation part. That's why I was giving you out of curiosity. I understand that you may not be able to understand what an objective function is, but still out of curiosity, I'm asking you this question. So it's okay if you don't understand what an objective function is at this time point. You will understand it in subsequent classes. Okay. Yes. Okay. So the first question is, can the farmer get all the 3 items across the river? So this question just asks, is there a solution? Right? So this is the question is similar to, is there a solution or not? Right? But this question, how many trips or passes are required? So this is quite similar to an objective function. So I can ask a different question, minimize the number of trips. Because when I ask how many trips and if you give me 100, so I would tell you कि ये बहुत ज़्यादा है. There is a solution which can be done with less number of trips, right? So this question can be formulated in a different way, asking you minimize the number of trips it take to cross the river. Given there is a solution to this problem. If there is no solution to the problem, you will not be able to do it in infinite number of trips. So this question has an objective function. The first question does not. All right. So let's see. So by the way, yes.
Looking at constraints and the objective, shall I means define the area of application of AI is nothing but the optimizing the solution for a particular problem.
This is for search.
As you said, 100 trips cannot means suffice or cannot work in a proper way, and all these we have to consider all these constraints in mind. So shall I say that with the given constraints and the objective, optimizing the problem is the main aim of the artificial intelligence?
No, you are correct. Not completely, just a little bit is missing. You are saying that it is the goal of AI, but goal of AI is not that. This is actually the goal of solution methods using AI. So what are we talking about? So if I go back, just let me go back once. Yes, so we are here, search algorithms, right? So that problem falls under the scope of search using AI.
Okay.
All right.
Okay.
Okay. So yeah, so I guess you must have tried. Again, the way you must have tried is trying multiple combinations, right? So you are seeing that if I do this, then what happens, and I do that, what happens? So yeah, that is a correct way to solve that problem. Might not be efficient or maybe efficient, we don't know, we have to check, but that is a correct way. So you see, an algorithm, there are two things to consider, whether it is correct or not. Second is whether is it efficient or not. So for example, I don't know how many of you have taken the course on algorithms, but there is a very broad idea of search algorithms. So when we talk about search algorithms, you can do a linear search. Like if there is a number from 1 to 100 and you want to search for, so like this, take it like this. So there is a bag and there are balls with numbered balls, and each of the ball are numbered from 1 to 100, and you're trying to find a ball with a number of 70. So a linear search, how will it work? You are picking a ball and seeing if the ball has that number or not. So this is one algorithm to find a solution to that problem, right? So is it correct? Yes, it is correct. It will at the end give you a ball if the ball is present, and if the ball is not present, it will tell you that the ball is not present. So this algorithm is correct. If it is efficient or not, it is a second question. So the algorithm is correct. Efficient or not, we have to check. Is there any other algorithm which can do the same task more efficiently? I don't know. You have to check, right? So there are two aspects of algorithms, whether it is correct or not, and whether it is efficient or not. Efficient both in time and space. We will talk about both of them later. Right? So yeah, so we are talking about this problem. Now, okay, so I should have kept a slide before this slide. So this is actually a state search problem. Yeah, search state problem. Either way, I don't remember. State search problem. So you can represent this problem in different states. So this problem is in this state, this problem is in this state, this problem is in this state, and you can connect those states similar to the way we did for nodes and edges. So you see, we are converting these problems to a graph. You will see that you may not have imagined that this problem could be converted into a graph, but we are going to do that. We'll convert this problem into nodes and edges, and then we'll use some search algorithms to find our solution. All right. So let me just take one slide, extra slide over here. How to do it?
You can press W in, if it is PPT, it can put.
It's not PPT actually. Achha, all right. So I'll just do it over here. Okay.
There is whiteboard. In
White.
MS Team, whiteboard is there. Option is there, whiteboard.
So this is not actually Microsoft software. This is not a Microsoft software. All right. So okay, just leave it. So you see, we can think of this problem as states. So one state, the initial state is what? F. So F is the farmer, goat, cabbage, and wolf or fox. What is it? Fox. So I'll just erase and fox, right? And the river. So this is one state, the initial state. Right? There are actions you can take. Some actions may be feasible to a state or may not be feasible, but there are some actions. For example, when I say like this F arrow, it means the farmer is in the boat going from left to right. There can be F G arrow. There can be F C arrow, and so those are different actions, by the way. There can be F. अच्छा fox को FO कर देते हैं, FO arrow. So there are 4 actions going from left to right. Similarly, there are 4 actions from right to left. So F this side arrow, FG this side arrow, FC this side arrow, and FFO this side arrow. All right. So there are 8 actions, 8 possible actions. Those are feasible or not, we have to check, but there are 8 actions. Is this clear? There are 8 possible actions, right? Any questions? Now, from any given state, so what we will do is we will make this a node. So this is the node 1. From this node, you can take some actions. What actions you can take? You can take any of these actions, right? You can take any of these 4 actions. So there can be 4 children of this node. So I will just draw one such children. Suppose I'm drawing this children. So I'm drawing this child. FO is over here. In between, I am taking FO and C is here. F, G, and arrow, and nothing here. So you see, what action did I take over here? The action I took is, okay, I'm sorry, just give me 1 minute. I'll just write it properly. There are 4 actions you can take. So the action which I'm taking is FG arrow. So this is the action I'm taking. The node which will, so the state which will be next is FO and C will be this end and FG will be in this end, right? This is the next state after that action is taken. Is that correct? So this is one state, this is another state, and this is the action we are taking. Is it correct? Is this correct?
Yes, it is.
Yes, sir. Yes.
You can create a tree. You can create a tree. So for, I'll just erase this part. You can now create a tree. And so on and so forth. And in this tree, you can perform a search. All right. So you see, we have connected.
Wait. When you have one twig of F and G with arrow, then
Yes.
what if it is fox and cabbage on one side?
No,
Okay.
F is actually farmer. Fox and cabbage in one side. Yes.
And the two parallel lines indicates the separation of rivers, river banks. Is it like that?
Yes.
Okay. Please continue.
Okay. So we will define now this the components of state search problem. All right. We will now define the components of state search problem for this example. What is a state? A configuration of farmer, fox, goat, and cabbage across the river. So this is one state. So this is state 1. This is state 2. You have to define an initial state. So we have defined the initial state. State 1 is the initial state. What is the goal state? So goal state is what? The river should be here and F, C, G, FO. This is the goal state, right? This is where we want to go. From this point 1 or node 1, we want to go to this node, whatever the number is, doesn't matter. This is the goal state. Okay, I'm proceeding, right? What are the actions we can take? So I have already mentioned the action. These are the 8 actions you can take, right? These are the 8 actions you can take. It may be feasible for a state or not, that is a different question, but there are 8 possible actions, right? You can draw a transition model. So what is a transition model? When I'm drawing this tree is a transition model. So from one node you can go to another node. So what is this actually? So what is a transition model? Thoda mathematics likh rahe hain, I'm writing a little bit mathematics, please understand. So this is a model, transition model. It takes input a state and an action, and it can give you a state. All right. So what does it mean? You are giving state 1 to the transition model and you are saying I am doing this action. So the input is state and action, and the transition model will give you the next state it will be in. So the transition model will give you this state. All right. So this is what a transition model is. For a given state and an action, it will give you the next possible action. And if that action is not possible, it will tell you that this action is not possible because there is no state which will result from this state and action. All right. So this is what a transition model is. Describe valid state changes. Valid means some actions may not be feasible for a state, so it will only give you valid state transition. So it's transitioning from one state to the other. How are you transitioning? Performing an action. So you are staying at a node or at a state. You are saying that I will perform this action and I'll go to the next node or the next state. So this is a transition model, transition from one state to the other, right? And search space. The search space is actually the whole tree. The whole tree is your search space. In that search space, you're trying to find a path from the initial node to the goal node. All right. So this is what a search tree is. The collection of all possible configurations of the farmers, goats, cat, and cabbage across the river can be visualized as a directed graph. So I told you in the motivation slides that a collection of node and edges are actually known as graph. All right. So a collection of nodes, some nodes and some edges in between those nodes, are known as graph. All right. So a directed graph, it means it has an arrow. Each edge has an arrow. Directed graph means from this node you can go to that node. A directed graph where states and nodes and actions are. So when states are nodes and action are edges connecting those nodes. I hope it is clear. If it is not, you can just stop me, please. Huh? Now, what are the components we have discussed? We have discussed what are states. We have discussed the initial state. We have discussed the goal state. We have discussed the actions we can take. We now know from one state what will be my next state given one action. We also know the complete diagram, the complete state space, right? Now the next question is goal test. So whether I am at the goal node or not, there should be a test. Suppose I am at a state which is 3. So I am in a state 3. Whether it is the goal node or not, there should be some test telling me कि हाँ यही goal node है. This is the goal state you want to be in. So there should be a test to tell you कि this is the node you want to reach. So for example, in a maze problem, So this is open and this is the end. So this is the start and this is the end, right? And there can be multiple ways to go to that end path. So what is a goal test? So at each of the, so you can just divide this into multiple blocks, right? And there are connections to go from one block to the other. So you can say if this block is at the end state or not. So that is the goal test. You are checking this node is the final node you want to reach or not, right? So this is a goal test. So a trivial example can be in Nokia phones there was a snake game. So that snake had to eat some food. So what was the goal test? Whether that snake head had touched that dot or not. So that can be a test telling the snake, yes, you have eaten, just grow. So there should be a test to tell you have reached the goal node. Otherwise you will be lost in the search space. You will not be able to tell you have reached the goal or not. All right. And there can be path cost. So taking one path can be costlier than the other path. For example, so I was talking about this objective function. So you can go from one node to the other node using, so for example, you can solve this problem with 100 passes of the river. But we don't want that, right? इतना ज़्यादा paths का ज़रूरत नहीं है. There is another path which has less number of trips. So each path over here is a cost. So I'm saying passing the river once has a cost of 1. Passing the river twice has a cost of 2. Passing the river thrice has a cost of 3, and so on. So if you have a solution with a cost of 100, I don't know if it is good or not. There may be a solution with a cost of less than 100. So those are the path cost. All right. So this is how we are transforming this problem to a state search. क्या है actually में? State search, state space search, state space search. Okay. Is this okay? Now we'll actually define the components of state space search. What is a state? A specific configuration of an agent in its environment. So for our example, the arrangement of farmer, fox, goats and cabbage. All right. So I will give you one more example of this kind of problem, state space search, and you have to tell me what will be the various components. All right. So this will be one task you will do in this class itself. So what is state we have defined? What is an initial state? The starting point for the search algorithm. So where you are starting. So for our example, all the entities were in the left bank of the river. What are the actions you can take? Options available in a state defined as a function returning the executable action. So this is a technical term. So I was telling you there is a transition model, and each transition model takes input as action and a state. So what is an action? An action tells you that if you are in this state, you can take this kind of action. So it is actually so in mathematical term, if you don't want to understand this, it is not important because these are definitions, but actions are all possible actions you can take from a given state. Transition model, so it tells you given an action and a state, what will be the next resulting state. State search, state space, all reachable states from the initial state throughout our sequence of actions. So जो भी sequence हम लोग कर सकते हैं initial state से, all possible sequence will comprise your state space. Goal test, so there should be a criteria to determine if the goal state is reached. Otherwise you will be lost in the space. You will search forever or until you have exhausted the whole space. So there should be a test to tell you ki it's over, you don't have to search anymore. All right, so there should be a goal test and a path cost. So we talked about what a path cost is. Each action has a cost. If you are performing this action, you will incur some cost. All right. So for our example, it was the number of trips the farmer is making across the river. All right. So is this clear? Then we'll move on to the next discussion.
Does path cost mean the number of trees which are made in the state space?
No.
So that will not be the path cost, right? Okay.
No. You see, when you are giving a solution to a problem. So you are saying from the initial node, you have a path that takes you to the goal node, right? So you have a path cost कि यहाँ से यहाँ जाने में I took 14 travels of the city. So that is the path cost going from initial node to the final node. What is the cost you incurred to go from start to end? You can have multiple paths, and each path may have different path cost. In optimization problem, in an optimization problem, we are trying to minimize this path cost for this kind of problems. What is the minimum cost you can take going from the initial node to the final node? Okay.
Yes, sir.
So this is the same problem which we started with in today's class. Now think about, so you do this time, think about what should be the, this I'll just put it here, what should be the state, initial state, action, transition model, state space, goal test, and path cost. All right. So what is the problem? The tracing problem. I hope you are clear with the problem because we did it. So these are the different components. Take 5-10 minutes, think about all of this because this is how you will learn. And anybody if has a doubt, you can ask me now. Right.
Hello.
So yes, yes.
Hello, sir. Can you describe the action state again? That one you have made one bracket in previous slide.
Sorry, I could not understand. Sorry.
In previous slide, you have described about the action state.
Yes.
Yes, sir. Can you describe that again?
So what are actions? Actions are
This one, sir. One bracket you have given, no? In second bracket.
over here.
No, sir. This one.
What bracket?
There's a F arrow, FG arrow.
Right. So I am saying this arrow. You are asking about the arrow, right?
Yes, yes. I want to understand this particular question.
I'm saying, okay. When I'm saying F arrow, this is an action that the farmer is on a boat moving to the right. When I say F, this side arrow, it is just a representation, by the way. You can represent it anyway. This means the farmer is on the boat moving to the left side.
Achha. Another in right side, it is having arrow in the opposite direction. That means farmer is again coming back or what?
So this is the river. So if it is like this, so the farmer is going this way. And if it is this way, then the farmer is going this way. This is one way of representation. You can represent it in any other way. It doesn't matter. You have to understand. The thing is, you have to understand what does this action mean. I have represented it in this way. You can represent it in any way you want.
Okay. Okay, sir. Thank you, sir.
Also represent like this. F is side mein arrow and F is side mein arrow. So this is also the way you can represent. It is up to you.
Okay. Okay, sir. Thank you, sir.
Yes. So I was saying, shall we proceed, or do you want 1 or 2 more minutes?
2 more minutes.
Okay. Anyone has any doubt or concern? See, you are free to ask questions. All right. So if you are asking a wrong question, it doesn't matter. The thing is, if you ask question, then only you'll understand better. So please feel free to ask question. There is no restriction that you are always have to ask correct questions.
So the state space diagram, we have started with first fox and goat. And
Sorry, ma'am?
In the state space diagram, sir, what you have drawn, we have started with fox and goat. And leaving the beef and cabbage on the one side of it, right? So in that itself, we can go further with the actions.
Yes. So this is actually this node, right? Okay. This is
till the goal.
Then it can go further down.
Go further. Until the goal is reached, I can draw the diagram in that path.
No, it may happen that this node will not reach the goal node. It may happen that it will not reach the goal node, right? See, you have some constraints, like you cannot leave the, so suppose you have taken, so you are in a state like this. So from the initial state I will do, right? So this is the initial state. So what was the initial state? F, C, G, F, O. This was the initial state, right? Node 1. So suppose you are taking an action F, O, and you are taking cabbage with you, right? So suppose you are doing this action. Now what will be the node you will have? You will have, sorry, not FO, it is F. I just erase this. It's just F. So what will be the node you will have? It is FO and G, and this will have F and C, right? So this is actually not feasible. This is an infeasible solution. So over there the tree will end. That means इसका नीचे और कुछ नहीं हो सकता. This state you have taken. इसके बाद it's not possible, because the fox and goat, if they are together, then game over, like, right? So at this node you cannot go further.
That's fine.
Yes, tell me.
This is the data.
Okay, so these are how are you handling constraint. All right, so that is a different thing in this problem we have constraint. Some problems may not have constraints. So these are ways of handling constraints. So one way we have handled a constraint, one more constraint is the actions. You see in the actions, we have said only farmer can go, or farmer and goat can go, or farmer and cabbage can go, or farmer and fox can go. We have not said that 3 of them can go. Or so those are the constraints we have already enforced in the action space. Some kind of constraints are there as well, right?
Okay, sir.
Boat capacity constraints are there. Right, so we should proceed, I guess. So yeah, anybody can tell me what is the state. So first is state. What can be a state for this problem?
State will be the nodes.
All the nodes.
All the nodes. So you're saying over here. So we should differentiate this node and the tree we are talking about. So you are talking about the nodes in this diagram, right? Diagram tracing diagram. This problem, right?
Yes.
This you're saying is the state for this problem.
Yes.
So how will you distinguish between multiple states if this is your state? So how will you say that this is one state and this is the other state if you're saying this is a state?
As per the definition, the arrangement of all the agents in the instant case are the nodes. So number of a specific configuration of an agent. Yeah.
This is actually talking about the problem on hand. So over here it is about whatever problem you. So actually this is coming from definition. That's why an agent term is used. So this is coming from some definition, some other definition, right? It is the configuration of the problem you can think. So think about it as a problem, configuration of the problem. It means that the AI agent is in that environment, right? That he's actually deciding from this node he has to go to that node. So what is the specific configuration the agent is in? वो environment में जो है, what is that environment? उस current position में. So that is where the agent is coming from. Yes, so anybody else can try. What can be a state of this problem? Any state, not important initial state or any other, any one state or two state.
So starting from the bottom node to the rightmost node, or starting from bottom node to the top node.
I don't think you are correct. Actually, I don't understand what you are saying completely, so I don't know if you're correct or not. So anyone else wants to try? I'll give you the solution, but anybody else wants to try?
State can be any node.
Any node. So you're saying that this is one state. This is, so yeah, this. So if this is, I'll name 1, 2, 3, 4, and 5. So you're saying this is one state. This is one state. This is one state, and so on. Are you saying like that?
Yeah, because we can start from any node, right?
Right. So how will you say that you are transitioning from one state to the other? So what does it mean from going from node 1 to going to node 3?
We can give the name of the branches as A, B, C, D. So
Yes.
from 1 to 3, yeah, we can that transition through that B will be the transition. The states are these 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So using that, we can make the entire matrix from one node to another possible nodes, and the connecting through the branches. There may be from one node to multiple nodes we can reach through those transition branches.
Right. So I will just tell again what is the states. So you see any configuration of this. So what is the configuration now? So I'm just giving more terms. So suppose I have started like this and I was here. So arrows must be there, by the way. So this is one state. All right. So this can be one state. Any other thing can be another state. So this, and this can be another state, right? And from this state, so suppose this is state A and this is state B. So from this state, what state can you reach? So you are here what state you can reach? You can just go over here. So this, and this, right? So only one possible action is there from this state to this state, right? From this state to this state, there is only one possible action. So now you understand what is a state. A state is from one some tracing you have done, that is one state, and you're going to another state by increasing your one trace. We can write this more appropriately what sir was suggesting. I'll tell you that also. But is this clear? What is a state?
Can a blank, completely blank without even starting can be a state?
That is an initial state. When all the nodes, all the over here, all is empty, that is the initial state. So that was the second question. What is the initial state? So this is the initial state.
So shall I say that for this particular diagram tracing problem, there are 5C1, 5C2, 5C3, 5C4, 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5 possible states. C stands for combination.
If you are trying to do that way, so I will just explain that way also. So suppose I will name these paths. I will name this path as small a, b, c, d, right? So a, b, c, d, e, f, g, and h. So what can be one state? You can say a, b is one state. From here you can go to a, b, c, or you can go to a, b, d, right? So you are going like this from a to b, and you are saying from a to b I can go to c. So a, b, c, or you can go from a to b, or you can go to d. So these can be also states, right? These are also states. So starting from this 2, or you can also use the nodes. You can also use the nodes. So you say start with 2, I'll go to 1, and from 1 I'll go to 3, and this is one state. From this state you can reach from 2, 3, 1. You can just go to 2 again, or you can go to 2, 1, 3, and 4, right? So you can go from 2, 1, 3 to 2, 1, 2, 1, 3, 2, and 2, 1, 3, 4, right? These are states. So this is state 1, state 2, state 3. Is this clear?
Yes, sir.
Right? Everybody, is it clear?
Yes, sir.
Yeah, right. So I'll just erase some portion. Right. So we know what a state is now. We know what the initial state is. Now what are the actions? We have already discussed what the action is. Just going to the next node. Again, node and node is getting there's some confusion. So I'm saying that tracing one more line is a action I can take. So in one state there can be multiple actions, or there can be very limited number of actions depending upon the state you are in. Transition model. So this is a transition model. So you are here, you can go over here. So this is one transition model. What is the state space? All possible actions you can take from the starting state. All possible such actions, the combination of everything, collection of everything, not combination, collection of everything will become the state space. What is the goal test? The goal test is all you have, it is completed. This diagram is completed is the goal test, right? And the path cost. So over here, the path cost is simply you one line, that is one cost.
Just a question that why can't if a line is drawn twice can be a goal test here?
So you are saying that how will we prevent retracing a line? That is the question.
Yes, that like if let's say if from 1 to 2 that line is drawn twice, why can't that be a goal test? That's just the question.
So when you are building this model, you have to restrict from this state. So for example, from state A, what is the state A? So you are going this way, you are going this way, and you are going this way. This is state A. So when you are building the model, you will tell the model that you cannot go from this and retrace the path again. So you can just not do this. So I'll just draw it more.
Will that come under constraints then?
Yes, those are constraints. You are not.
That are okay.
You cannot do it. You cannot do this. You cannot retrace a path. So in the mod, you have to tell.
That will be then constraint, and this will be final, will be the goal test. Okay.
Yes.
Thank you.
And goal test path cost. Path cost is what? So over here it is trivial because it will always be, whenever you reach a goal, it will always be the number of lines you took, right? It is trivial over here. Only it is a constraint satisfaction problem. It doesn't have an objective, right? You are not minimizing something. Is this clear? If this was the problem of Chinese postman, then each path had a cost. So if I go back to Chinese postman problem, just 1 minute. If I go back to the Chinese postman problem, this problem, so you see each path had a cost. Over there, when you have completed the problem, when the goal has reached, then you have to compare what was the path cost, and you have to search the whole tree to check which goal, so which path you have taken from the initial node to the final node, which has the least cost, and then only you will be able to tell if this is the least cost path. All right. So this algorithm, which I am telling you, start from the initial node, go down, go down, go down, explore the whole tree. That algorithm is known as backtracking algorithm. All right. So this is an algorithm. I have not mentioned it over here, but this algorithm is known as backtracking algorithm. What are you doing? You are actually exploring the whole tree. So I'll just make it clear with, you see, for this problem, what are we doing? We are starting at the initial node and we don't care what is the path cost, because path cost is the same. Over here it will be 1, 2, 3, 4, 5, 6, 7, 8. 8 is the path cost. Whichever path you take from the initial node to the final node, the path cost will be 8. Is this clear? This statement clear? If you are in the initial node and you reach the final node, the path cost will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Path cost will be 8, right? कोई भी आप पाथ लीजिए इनिशियल नोड से फाइनल नोड तक 8 ही होगा. Is it clear? You see, you have to ask questions or tell something, because if it is not clear, then it will be difficult, right? So when I'm saying the path cost is same, so backtracking algorithm can stop. So it need not explore the whole tree. When it has reached this goal state, then he can say ki, I have a goal, I have the goal, right? So I don't need to search the whole tree, because all the goals will have the same path cost. So us case mein, you are safe. You don't need to search the whole tree. But think about the Chinese postman problem. You don't know, you have reached the goal, but you don't know if it is the best path you have taken. So in such cases, you have to explore the whole tree. Only when you have explored the whole tree, then only you will be able to say, yes, this is the path which gives me the least cost. Is this idea clear? I will take this in the next class as well, because over there we will discuss algorithms. In this class, we are not discussing algorithm, but yet I have told you.
That is actually optimization algorithm you are saying. So there may be multiple solution, out of which one solution will be the optimized solution. So probably there we have to explore the entire tree. However, here there is no optimization algorithm. Here it is more constraint driven algorithm, that we have to travel all and don't travel any branch 2 times. So there probably exhaustive search is required. Is it like that?
Yes. So one correction, everything you said was correct. Just one small correction. It might happen that there are multiple optimal solutions. So you have a solution, and the value the path cost which you incurred to come to that solution, there are other solutions as well with the same cost. So there can be multiple optimal solutions. Otherwise, everything you said was correct. All right. So I am asking again, is there any doubt? Today,
so for this problem from initial state to next state, actually from each node to another node, whatever the connections are there, so all those will be at the second level, the states. Like here, there will be for this problem. So from the initial state to the next state, actually there might be number of branches are 8. So next state
Yes.
will be 8.
Yes.
Is
You are
it like that?
Yes, you are correct. You are correct. So from this node, there can be 8 possible next node. You can start from here, not 8 actually, there will be 16. So you can start from here to here, or you can start from here to here. So there can be 16 possible children.
Okay, yes.
Right?
Yes.
Okay, so I will just summarize. I have not completed yet what I was planning. So you see, in today's class, we have not seen algorithms to solve a search problem. I just gave you an idea how search problems are solved using a backtracking algorithm. We will discuss search algorithms in detail in our subsequent classes. But today we are just discussing how to identify the components of a state space search. All right. So again, I'll just reiterate what are the paths. So you can just go through. I'll just give you this slide. So whatever we have discussed, it is written over here. Actions, transition model, state space, goal test, and path cost. All right. So summary. So how do we model this kind of problems? You have to identify the state, the initial state. You have to identify. So you see, in some problems, identifying a state also will become difficult. So you have to be clever in identifying states of a problem, and then only you will be able to tell this is my initial state. So you require experience in such cases. So yeah, this is important to realize. Then you have to identify transition models, then state space, goal test, and path cost. All right. So identifying a problem, if it can be solved using state space search or not, that is also what you have to learn. Yes, this problem can be solved using this type of approach. Whether this approach is a good approach or a bad approach, we are not talking about that yet. We are saying this problem can be solved using this approach. There may be some other approach which is even better than this approach. We will see those approaches. But for today, this problem can be formulated as this kind of problem, like state space search. All right. So this is the summary. Okay. So I don't know how. Okay. So you see, we are actually at the end of our class, but I'll take few minutes. So what is a search problem? A search problem involves finding a solution from a set of possible configuration or states, often under constraints and rules. So this is what we have seen. We are searching for something. So over there we were searching for a path going from one state to the other. There can be other search problems as well, right? So but in state space search, we are generally looking for a path. So for example, Google Maps, when you say that this is a destination I want to go, Google uses some algorithm, maybe not the backtracking algorithm because it is not a very good algorithm. Google uses some algorithm to give you a path from your current location to that location using all the states you can be. So you can go from here to a corner, or not corner, what will you say? A place where you can turn. So yeah, so there can be multiple paths you can take from your current location to the final location. So that can also be modeled as this state space search, finding the shortest path between A and B. All right. Okay, so this will be the last part of this lecture. So yes.
Just a question in that Google example which you were telling. So the time will be the path cost there.
Yes. In that case, the path cost will be time.
Okay. Thank you.
Right. So I have taken some examples. So you may ask कि sir ये जो भी आपने दिखाया ये सब का applications क्या है? So here are the applications of search problems. Maze navigation. So that's Google. What I gave Google Maps example. It is actually a navigation problem. So there can be maze navigation also. So for example, you are playing Pac-Man or any other game, that snake game I told you. It had rules that you cannot go to a wall, you cannot hit a wall. So those are maze navigation problems, right? So those are the constraints, and those are kind of problems where you can model that problem using this idea. Route planning problem. So finding the shortest path between two locations in a map. Puzzle solving problem. So for example, Rubik's Cube. So you can think a configuration of a Rubik's Cube as a state. And when you move the Rubik's Cube in one direction, that is an action you are taking. and you're changing the state of that Rubik's cube from one state to the other. And using this idea, I don't know if it is, I am telling you this is not a good algorithm to solve backtracking algorithm, but you can model the Rubik's cube problem using this idea, state space search idea, right? You are at a particular state, you want to go to a goal state. You can take multiple actions and then you can reach the goal state, right? What is the objective? Objective is to minimize the number of actions you are taking to reach that goal state. And that is how you can solve a Rubik's puzzle problem, right? Rubik's cube problem. All right, so what are the constraints? So you must have a valid configuration, and so Rubik's cube में क्या constraint हो सकता है that when you have a configuration that you cannot have more than 9 blocks of the same color or something like that. So there can be some constraints. Some problem might not have constraint as well. All right. So other example can be game playing. So an AI agent must determine the best move in a game like chess or tic-tac-toe. So there are games like chess which you can model using this approach. Capture a chess game in between. You can think about what are the actions you can take from here. And just think about it, the sheer number of possible states in a chess. And over there you will realize that it will become exponential. From one chess game, one capture of the chess game, you can take multiple actions, and those actions can have states which can lead you to multiple other states, and those can lead you to multiple other states, and so on and so forth. So you will have an exponential explosion of states eventually for chess games. And that is why for a long period of time, people could not come up with a AI agent which could play chess very efficiently. All right, so that was one big reason about that. And tic-tac-toe also you can think about you are at a state, then your one agent is doing a cross. So over there, this is an adversarial search. We will see that in our lecture. What is that adversarial search? So you are playing and there is someone else who is sabotaging your game. So that is known as adversarial search, and we will see that as well. Robotic navigation. So again, you are going from one place to the other and so on. Resource allocation. So distributing limited resources among competing agents and so on. All right, so conclusion. So importance of search problems. Search problems are fundamentals in the various AI applications. So whatever AI do, there are some kind of search involved in that. Anything actually you're trying to go from one place to the other, also you are in your mind thinking an optimization problem. So think about I want to go to a canteen. So what do you think? I should take this path. I shouldn't take this path. This will take a lot of time. Or maybe रात को यहाँ पे this road is very busy. I will take the other road because that will take less amount of time. So what are you doing? You are actually solving a optimization problem. You may not solve it optimally, but you are trying to solve an optimization problem. So AI agents in those situations also will solve this kind of search problems. Require efficient strategies to explore and find solutions to complex environments. All right, so this was it I had planned for today's lecture. So what is this now? This is about Python programming. So because we are out of time, we will discuss this later. All right. So what I was thinking is I will take extra classes to discuss Python separately. And these Sundays I will keep for the discussion of our lecture, and Tuesdays I will keep introductory classes for Python, 1 or 2 classes on Tuesdays. But this Tuesday I'll keep it free because this is the first class and I don't want to surprise you with another class on Tuesday. We can work it out later. All right. So this is it. Please join that Google Classroom, because over there you will find everything in one place. Go there today and solve that quiz. Give me feedback. I have not uploaded any feedback form, by the way, so yeah, it will work. And I apologize for this. I have used another slide, so that's why I have written here computational thinking. Achha, any doubt or concern before we?
I have a doubt.
Yes.
This route optimization problem, the earlier days, this networking, in computer networking, the route optimization was doing. So superficially, means what is the difference whenever we are going for those algorithm like Dijkstra or some algorithm? and the route optimization through AI. There also cost optimization was there. Here also cost optimization. There were probably those were more analytical model. What is the difference?
I don't have much knowledge about route optimization, so I may not be a correct person to answer this question. I don't have knowledge about route optimization problems.
Okay. Thank you.
If you please provide some reference books or like something on this class, on the material which you taught today, so it will be very much helpful. And where we can get some problems like this with answers, so that we can practice ourselves these problems.
So in the first course handout, I have mentioned about reference books. For problems I have not mentioned, I'll try to find some resources for problems as well.
Okay, thank you.
So others, you can leave. I will get attendance in this meet itself. I'll share the attendance in the group. You just check if it is correct or not. All right. And do that quiz, because the deadline of that quiz is 1st October, this Tuesday. So submit it before that deadline. Anybody has any doubt, or should I end the meeting?
Do we discuss this answer for this?
Yes, we will discuss the answers. Yes.
Okay.
Sir, could we connect personally for doubts if we have any?
So if you have doubt, post it in the Google Classroom. We can discuss it over there. And any other specific doubt, you can text me.
Okay, sir, sure. I'll text you personally, sir.
Okay.
Thank you.
So I guess no other questions. All right. Thank you. Thank you for joining. I hope you enjoyed today's class. So I'll end the meeting now.